Today we're going to talk about a very fundamental concept that we need to begin understanding the constitutive relationships between elements on a system. So I'm going to show you the what we call the elements that cause and what are the effect of those um, inputs. For example, if you apply a force on a mass, the mass moves. What's considered the cause, what's the effect, and so on. We need those concepts to be able to understand the constitutive equations of individual elements. So let's consider the example we have on the screen and analyze it in more detail. Let's see. In here we have this mass, and then we have the force, all right, that you see here. And as a consequence of the force, the mass is going to move. And the mass is going to move to a different place. The mass may come, let's say, why don't we put it in dotted lines over here as the new position of that mass. Yeah. So this would be the position at, let's call it at x1. And then there would be the position at x of 2. So what is the origin of this motion? So why don't we save here origin of motion? What's the origin of the motion? This would be application of the force, right? So you see application of force. Okay, so this one, we could call it the cause. And what would be the result of this application of this force? You would say result is in motion of mass. With some velocity, you would say with velocity, dx dt, which we know as x dot. So this is the effect, cause and effect. The effect, in fact, is so the cause is the force, the effect is the velocity. Okay? Cause is the force, the effect is the velocity. You may say, can we specify the velocity and know the force? Think about that. I would say yes, and let's explain why I say that. Okay, so let's just draw this is a good example. Let's say this is a tire, right? And I am going to have that tire adjust to the terrain like the tire is where the tire is going. Let's say terrain is like that. So this is a tire with the moment of inertia j here, and you have that the velocity of this, yeah. So obviously it moves with some velocity in the x direction, and because it's rolling on the ground, it turns with omega, right? So can we look at the cause and the effect in this case? What is the cause of the motion for this wheel is going along this profile, is going up and down, and of course it's rolling too. So does the floor produce a force input or a velocity input? That's the question. So when we talk about cause and effect, we can raise the question. You can say, can the velocity be an input? You see, in this case of the wheel, we know that the wheel is supposed to follow the profile. You can say wheel, in this case, follows profile. Yeah, follow the profile. I would say wheel follows the profile. You can say it's forced to follow the profile. Yeah, and because it's forced to follow the profile, this is the change of position. Change of position is a function of time. So delta y, delta t, this in fact is the vertical velocity. See? So of course, granted, it changes also in the x direction, but the fact is that the input to this, the force is the wheel is forced to follow the profile. Because of that, the input from the ground is a velocity input. So we could go up to the example that we had in the previous example. Here you could say that if this is the input element in here that we call force, then this is applied on the other element, which is mass, and then as a result of this, see, so this is the force, this is the response velocity. Okay. In this other case that we have on the wheel case, if we do the same thing, you could say this is the ground. Which is forcing the wheel to follow a certain profile. In this particular case, ground and then put wheel here. And the wheel responds. So the input for this is a velocity input. And the consequence of this is the force. So you see, you could follow in a motorcycle the profile of this suspension system, this force to follow the vertical profile. And you will say, yeah, I fall into a um, hole or depression on the road like this, and I feel a force. Well, yes, but the point here is that the input to the system, in this case you and the wheel on the ground, is a velocity input, and the consequence or the effect of that is the force. So in conclusion, the conclusion I want to reach is that the force can be the input. In this case, this is the cause, and the result results in velocity. This would be the effect. Yeah? But also you could say conclusion 1. But conclusion 2, as we have seen here on this example, on this suspension example, you have a situation where the velocity can be the input. So this is the cause in this case, and the result in force. So this is the effect in this case. So we can actually summarize this in a little nicer way if we consider this would be the element that's acting, this would be the element that is reacting. That's another way of saying what I'm trying to say. This is the action reaction. So this would be the action, this would be the reaction. Okay? So why don't we look at the more detailed example, detailed graph of what we're trying to talk about, this concept of causality, which in fact can be also used to explain the differences and similarities between expressing this say the system in a block diagram form, or using a new set of symbols called bond graphs. So why don't we say here, you could say more general in here, you know that this element A applies a force on B, B responds with the velocity. So we are going to use the letter E for force and the letter F for velocity in this case. But I could generalize and say if element A applies a force on element B, B will move and will respond with a velocity. That's what this graph means. This graph is the reverse, because here says if B in this case acts on A responds with a velocity. So if B were to act on A with an effort, A will respond with a velocity. So this is again, this is the cause and effect. So in this case, this would be the cause, this would be the effect, and in this case, the cause and the effect. So do you see what I mean? If A applies a force, B acquires a velocity. If B applies or forces A to follow a profile, there is a velocity input, and then we will have the reaction, which would be this F. Now, there is a notation that we can use. Let me see that before I say that. What I'm saying is that A can inflict a velocity on B, and B will respond with a force. That's what I mean to say. Now, this fundamental concept can be stated or explained on this little with using this little picture in here called a bond graph model. This is a line which we are going from now on to call it flow, and this causal mark is going to be the effort variable. So it's the equivalent of saying that using the vertical bar, I am expressing how the force applies between those two elements, and using the line, how the velocity result happens. So this is the typical bond graph equivalent of this block diagram. That means that A, you see as if this would be a little piston in here, pushes on B, B responds with a flow. And this is the opposite. If B pushes on A responds with a flow. That's what it means. Or you could say that the way we're saying here, if A causes the flow to occur in B, the response is a force. See? So that's a very basic concept on how we apply this idea of the cause and effect, and the idea of which cause is the flow and which cause is the effort. Like in this case, A applies the effort on B, B responds with a flow. In this case, A applies a flow on B, B responds with an effort. See, that's how it works. So that's the very basic concept of cause and effect, or so-called causality.